Welcome everyone. Today, we're diving into a massive shift in artificial intelligence, exploring the architectural, compute, and organizational blueprints required for this new post-training era. These insights are distilled directly from Luo Fuli, head of the Xiaomi Large Model Team, giving us a front-row seat to the agentic paradigm. Let's kick things off with an executive summary of this revolution. First and foremost, the era of pre-training dominance is officially over. The definitive war for 2026 will be fought entirely in post-training and agent frameworks. Second, size matters. A 1 trillion parameter foundational model is now the absolute minimum requirement to play in the top-tier agent space and match frontier models. Finally, the ultimate objective over the next 1 to 2 years is AI training AI, building an AI that can conduct autonomous research to create a self-improving, closed-loop system. To really grasp this shift, let's compare the old chatbot era, which ran roughly from 2022 to 2024, with the new agent era of 2025 and beyond. Back then, the primary focus was pre-training. Today, it's all about post-training. Our horizons have expanded dramatically, moving from short, multi-turn chats to long-horizon, multi-day task execution. The human role has evolved too. We used to be micromanagers trying to fix specific lines of code, but now we are high-level orchestrators, simply providing constraints, business logic, and goals. Consequently, our evaluations have shifted from static benchmark scores to measuring real-world, end-to-end task success rates. Luo Fuli actually experienced an epiphany over 3 intense days using the Open Cloud framework. On day 1, the spark was realizing the framework had proactive memory and soul, as it autonomously perceived time and context, even suggesting she go to sleep at 2 a.m. By day 2, she was delegating complex real-world management tasks, like team building and personnel screening, and the agent delivered structured, actionable outputs. Day 3 was the real game changer. The agent acted as a co-researcher, building user simulators to generate rich synthetic data for SFT and RL, proving that AI can directly accelerate its own development. This brings us to the co-evolution flywheel. On one side, the agent framework compensates for model flaws by using memory hierarchies, proactive scheduling, and tool routing. On the other side, as the foundational LLM scales in intelligence, it can actually rewrite, optimize, and completely upgrade the framework's architecture. The core insight here is that open-source frameworks progress exponentially because they absorb the swarm intelligence of the developer community, constantly feeding better constraints back to the model. Because of this, the way we allocate compute must radically change. The historic 5-to-1 ratio favoring pre-training is completely dead. Compute is now the ultimate bottleneck for unlocking agentic workflows, leading to a new 3-to-1 compute ratio. A massive 60% of the cluster is now dedicated to advanced research and exploration, because ideation takes hours and running parallel experiments for agentic architectures demands massive GPU resources. The remaining compute is split evenly, 20% to post-training and 20% to pre-training. However, this shift introduces the long context dilemma. Agent workflows require massive context windows to execute multi-day tasks, but standard architectures become paralyzingly slow and financially unviable at this scale. The reality is that models aren't natively trained on 1 million token contexts. Instead, they are trained to understand long contexts which are then activated during inference. The ultimate goal is clear: maximize tokens per second while drastically minimizing the KV cache footprint. So, how do we fix this? Let's look under the hood at speed and sparsity. Instead of standard architectures that suffer from serial processing bottlenecks and KV cache overloads, we use a hybrid approach. Hybrid attention achieves an extreme 7-to-1 sparsity ratio between sliding window and full attention layers, radically compressing the KV cache and cutting costs. We combine this with multiple token prediction, or MTP, which functions like speculative decoding, using leftover compute capacity during inference to predict multiple tokens ahead simultaneously. The result is staggering, pushing 60 to 150 tokens per second on massive foundational models, and dropping the cost per token to viable levels for continuous agent loops. Next, we move to Omni-Perception. The guiding philosophy is that to execute actions in both the physical and digital worlds, agents require native, unified senses, not stitched-together models. The method involves forcing audio and video inputs into lossless, discrete tokens to unite them natively under a pure LLM framework. What emerges are native multimodal models that exhibit higher EQ and a profoundly deeper physical understanding of the world compared to text-only counterparts, even when using smaller parameter counts. To build these complex systems, our organizations have to mirror the swarm. Just as an AI multi-agent system relies on specialized agents cross-verifying each other to complete complex goals, the human organizational structure must be flat and hierarchy-free. The key insight is this: building artificial general intelligence requires the organization building it to operate exactly like the neural architecture itself, decentralized, flat, and highly communicative. This requires completely dissolving the traditional org chart. Before, we had a strict, siloed division between data, pre-train, and post-train teams. Now, those silos are gone, replaced by cross-pollination. Post-training requires an inherent understanding of data diversity, while pre-training requires a deep understanding of end goals and architectural realities. It's about prioritizing culture over KPIs, where a team of around 100 people is driven purely by passion, curiosity, and shared aha moments, completely rejecting corporate hierarchy to accelerate iteration. Looking ahead, the trajectory towards self-evolution shows human intervention dropping as AI capability soars. In the near term, the next 3 months, the capability gap between top-tier Chinese foundational models and frontier models will completely close. In the midterm, around 2025, expect a massive explosion in inference demand as agents become reliable and cheap enough to replace complex human workflows entirely. And in the long term, within 2 years, models will attain the intelligence of elite human researchers, generating their own hypotheses, writing their own agent frameworks, and achieving self-directed evolution. Ultimately, if we create models that replace 90% of tedious work, humans will finally have the time to pursue true scientific breakthroughs. AGI isn't the end of human research, it's the beginning of it. The ultimate goal of scaling parameters is not just to ace benchmarks, it is to model reality and liberate human potential. Thank you.